Introduction to Principle of Superposition. When two waves cross each other's paths, their displacements combines at the point where they cross. For the surfer, the amplitude of the wave doubles where the two waves meet, resulting in him being thrown off his board. This process is called the superposition of waves. Superposition happens in all types of waves, and it produces many different effects such as stationary waves, interference, and diffraction. In this lesson, you will be able to explain the principle of superposition, explain the formation of standing waves, derive and interpret the standing wave equation, and distinguish between progressive and standing waves. Press play to observe what happens when two wave pulses traveling in opposite directions along a string meet. Use the scale to measure the amplitude of the pulses before, during, and after they meet. Using pause will help you do this. Answer: the initial amplitude of each pulse is 3 centimeters. When the two pulses meet, their displacements combine to give a larger pulse with an amplitude of 3 plus 3, which equals 6 centimeters. After combining, the pulses separate and return to their initial amplitude. This process is known as superposition. During superposition, the displacement of each pulse combines. When the resultant displacement is greater than the individual displacements, constructive superposition is said to have occurred. After superposition has occurred, each wave pulse continues traveling in its original direction with its initial amplitude. Click play to observe when two wave pulses of same amplitude but with displacement in opposite directions meet. At the instant the two waves meet, the resultant displacement is 0. This is an example of destructive superposition. Both constructive and destructive superpositions are explained by the principle of superposition. Click rewind and click play again. This time, click pause and step through to freeze the animation at the point the two waves meet. The principle of superposition states that the resultant displacement produced by two waves at a point is the vector sum of the individual displacements of the two waves. The interactive model shows two continuous waveforms in green and blue, adding to produce the resultant waveform in red. What is the amplitude of 1. Green wave, 2. Blue wave, and 3. Resultant wave? Answer: the blue and green waves each have an amplitude of 1 centimeter and the resultant has an amplitude of 2 centimeters. Increase the amplitude of the blue wave to 2 centimeters. What is the amplitude of the resultant wave? Answer: the amplitude of the resultant is now 2 centimeters plus 1 centimeter, which equals 3 centimeters. Is this constructive or destructive superposition? Answer: constructive superposition. What do you notice about the phase difference between the two waves? Answer: the blue and green waves are in phase with each other. The phase difference between them is 0. In this example, the phase difference between the blue and green waves has been changed to pi radians. The waves are said to be in antiphase. What is the amplitude of the resultant wave? Answer: the amplitude of the resultant wave is 0. Explain the process in terms of the principle of superposition. Answer: the principle of superposition states that the displacement of the resultant wave is the vector sum of the displacements of the two combining waves. If the combining two waves of equal amplitude are out of phase, the displacements are always equal and in opposite directions. The vector sum of the displacements is 0. If the amplitude of the resultant wave is 1 centimeter, A, what is the phase difference between the green and the blue wave? B, what is the amplitude of green wave? Answer: A, the phase difference between the blue and the green wave is pi radians. B, the amplitude of the green wave is 1 centimeter. Now, reinforce your understanding of the principle of superposition by using waves of different amplitudes and phase difference. Complete the table for the superposition of two waves with the same frequency at the same point. Summary: the principle of superposition states that the resultant displacement produced by two waves at a point is the vector sum of the individual displacements of the two waves. Constructive superposition occurs between two waves of the same frequency if they are in phase. Destructive superposition occurs between two waves of the same frequency if they are in antiphase.